Welcome to this presentation and demonstration of the Oracle Advanced Analytics option as applied to a fraud and anomaly detection use case. This is part 2 where I'll primarily cover the demo that I set up in the part 1 presentation. My name is Charlie Berger. I'm the Senior Director of Product Management for Data Mining and Advanced Analytics at Oracle, and you can reach me in that way. This is the legal disclaimer always required to show as Oracle employees. And now to summarize, the Oracle Advanced Analytics option is what we call the fastest way to deliver scalable enterprise-wide predictive analytics. Why? Because we keep the data inside the database and we allow you to mine the data, analyze the data in place rather than moving it to other more traditional statistical or data mining engines that require you to move the data to some other analytical platform. Here we're going to do it all inside the database. We're going to help you leverage the data that you manage inside your database to make better decisions, provide deeper insights, and provide even predictive analytics. We provide a comprehensive analytics platform on a very, very simple architecture. It is the database. So if you have the database, you can also analyze your data in place, and in doing so it provides what we consider to be the lowest total costs of ownership. You do not have to have separate analytical servers, separate analytical environments and staff. The people who manage and use the database can use the database also to perform the analytics directly there. And we provide graphical user interfaces, as primarily I'll show in this demonstration. You can also access the in-database functionality via the SQL API, or also you can use the R language to access those same algorithms and techniques, and also access other functionality from R to solve your problems. So we're going to cover fraud and anomaly detection. Our use case here is going to be an automobile insurance claims situation. So we have a number of insurance claims from automobile drivers, and we're going to see if we can find unusual occurrences in this data. So let's cut over to the actual product. And what I'm using here should look familiar to you. I'm using Oracle SQL Developer, so it looks familiar. I have connections to the database where I can access tables and views, or I can set up my Oracle Data Miner connection where I have projects and workflows where I will perform my analysis. So the very first thing I probably want to do is start with a data source. So I have different workflow editor nodes for dealing with data, transformations, handling unstructured data or text, building models, applying models, and various different nodes. And if you don't see exactly what you need to do in a node, of course you can always drop into SQL or perhaps use some R to handle a particular function. Once we set up our data that we're going to use, in this case we're going to pick the claims data set, then once I select that, and by the way I can have different schemas here. So one of the nice things about doing everything inside the database is I, as a data analyst, can have access to all sorts of different schemas here, and I can just sort of pick which ones I want and move them over to here and have access to that data. But I set up what data I want to analyze. I validates that these are the attributes that I want to mine, and then I have my data. So I'm doing this natively on tables and views inside the database, which is nice. And every time I do something, I'm laying down little SQL breadcrumbs for what I do. If I want to view the data, well, I view the data, and I can see it in terms of what columns. I can see the SQL that I generated behind the scenes to do what I'm doing. I can also generate graphs off that data. I can sort the data, let's say to sort it based on maybe the number of supplements in some sort of ascending order, and then now that is sorted. If I go over here and look for that, I'll find that all sorted. And I can do a lot of analysis just using pure SQL, but that's not what it's all about here. We're really trying to go a little bit further and do some actual analysis here. So one of the very first things I might do is just build a predictive model. So I can take an anomaly detection model, drop it onto our workflow, connect this to that, and I'm really all set and ready to go here. I can edit this and say I want to change some of the settings of my support vector machine model. I can change the inputs. I can change the algorithm settings to say whether that's a linear or a Gaussian type of model. There's a lot of things I can do there. But before I run off and do this, what I was going to do is just kind of scroll up a little bit here where I already have this set up, and I've done one of these. So I've built a model, and I've applied that model to some new data. So let's go into here and let's look and see what we've done. We've we've built a model, and now I have those attributes, and I can sort these based on groupings of age of vehicle or whatever, as these either positively or negatively. These are all negative coefficients, so these in fact strongly suggest that the data is more likely to be normal records, not anomalous. And that makes sense here because we're looking for things that are very, very rare. We have a small rate of fraud that we're dealing with, hopefully, and so we're really looking to find what are those things that stand out. Most of the attributes point towards normal, and we want to see, well, if we could flag everything that just is not so normal compared to the rest of the records, then that's what we're looking for. And this is a little bit like that old Big Bird thing on Sesame Street. Can you see which one of these several objects or things that's not like the others? That's essentially what we're doing here. So we build our models. At the end of this, we apply our models to, in this case, the same data. Now we could do the same or new data. We have these automatic settings here which I can turn off, and I can change the prediction probability into something like the likelihood to be normal or not normal, and there's various different ways I can apply that model. And I can also add in additional output here to carry along with my report and decide to have the predictions first and then carry along the rest of the results. So here, if I view these results, I have my predictions. Let's sort these. So I'm predicting things that are unusual, so ascending. Those will be the zeros first, and then the probability. So I'll do that descending. So I want to see everything that's likely to be a zero and the likelihood of it being a zero. So this record right here is the one that stands out the most. It's 63% likely to be unusual, so it's not an absolute slam dunk, but we think it's a little bit unusual. And if I sift through my data here, what might leap out to you as I kind of scroll by here at a slightly slow rate, for me, looking at this data, it's a Honda, and it is the valuation of this Honda is somewhere down here. It's more than $69,000. So that's a little bit weird. That may stand out to the algorithm as something that seems a little bit unusual. A Honda that's over 5 years old as being that highly valued is a little bit unusual. Now, because we can do this all in the database, it opens up a lot of opportunities. I want to show that to you next. I can visualize the data, which I probably should have covered earlier, but let me just show that briefly. I can view the age of the vehicle grouped by something. I can see the number of claims or the driver rating. I can do a bunch of histograms and statistical output of what I've done for the min, the max, the standard deviation of everything. And again, behind the scenes, I'm laying down all the SQL for what I'm doing. But I've visualized the data. Previously, I built this anomaly detection model, and I applied that data to that model, to itself really, and flagged those things that were most unusual. But one of the nice things, I think, is we have all these other algorithms, and they can be used in combination. So here I've actually done some clustering. Now I'll cover the clustering in a little bit greater detail in another YouTube video, but here let's take a look at the tree first. If I look at the total tree here, and I can go to my thumbnail over here and I can kind of start at the top, then most of these records look like this. Most of them are no change in the claim, the policy from the accident is more than 30 days, the deductible is $400, and I have the rule that describes what sort of normal is. If I go down each of these different sides here, I start to see, oh, here's some human or some person at the insurance company maybe has flagged this as possibly fraudulent. We'd like to maybe use that as an input, but maybe not take it as gospel. We want to kind of consider it among a bunch of other variables, and automatically, using machine learning techniques, flag those records that are the most anomalous compared to the rest of the population. So what we're doing here is we're sifting down through the tree, finding ever more homogeneous subpopulations, and then as we find a node here like cluster 12 where the rule says, well, if it's all perils and the age of vehicle is more than 7 years and it's a third party and we don't think it's fraudulent but it's a married person in a sedan of these age groups and on, then that becomes a segment unto itself. And here's another one where the rule is slightly different, and as you can see, there's different settings here. Well, I might want to compare these clusters. If I take, say, cluster 12 to, say, any other cluster, let's take cluster 17 that's popped up there right now, and I just take a few of these variables and kind of light them up here and see what I have, then on a multi-attribute level I can kind of see, well, the vehicle price are pretty low on the blue ones, but they span a range on the red ones. Most of the red ones are all perils and a little bit of collision, so they're mostly all perils, whereas the other ones span a spectrum. So I could assign the red one to some sort of label if I wanted to, and I just call it a label, or I can call these all perils here, perhaps. So if I do that, and I'm just going to say cancel so I don't change anything here, then what I get coming out of this, if I take that data, apply the cluster model that I just created to that data, then I get cluster assignments here. So here, I'm going to show you that I assign each record to the cluster that it's most likely to be a member of. Okay, and then after that, I use a row filter to filter just those records where, say, cluster ID equals 12. And I can add other sort of filters here. I have a whole sort of expression builder that I can use, and I can validate this because it's going to run 100% inside the database as SQL and SQL functions. And then for each of these separate streams, I'm going to apply a unique separate anomaly detection model that's going to be the theory here is that the model is going to be a little bit more accurate because it's going to be working on a population that's a little bit more homogeneous. Why? Because I took the time to cluster the model, build a clustering model, and sort of sift these records into more homogeneous populations. So think of how I would do that in, say, medical practice, where I have pediatric claims versus geriatric claims versus orthopedic, and so on. So that's what I'm doing. And I can, at the end of this, I can generate the SQL for everything I've done, select node and the dependent nodes, and I can immediately take this to deployment. So I can go from the data analyst to a production deployment rather quickly with Oracle. So that's really a nice advantage. And if I just wanted to go straight into code, I wanted to show you what's going on here. Here's where I set up the data. Under the hood, we're using these DBMS data mining functions. DBMS data mining create model. The name of the model is a claims model. That's the type of function. That's the view or table that I'm going to use. And that's the unique identifier and so on. So if I just run this, and at the end I'm going to use this model, you'll see what I'm doing here. I can just run this as straight from the API. It's building the model on about 20,000 records and about 25 attributes, and voila, it built a model and then used the model to sort those records in likelihood of being anomalous, not necessarily fraudulent, but we think they sort of stand out for the same sort of reasons I showed before. And all this can be easily automated. Okay, I can send this script off and schedule it or run it however I want. So I just want to go back to some slides and summarize. And then we'll wrap this up. So what we did was we used a number of different Oracle data mining nodes for accessing tables or views, perhaps doing transformations where I join things together. I used the Explore node. I did not do anything with the text, although I'll cover that in other YouTube presentations and demonstrations. But I used some of the modeling techniques here. I used the anomaly detection modeling techniques, and I used the clustering technique here. I did not use the clustering, but I always like to point that out because it's a very, sort of powerful technique, and we would ingest that data just as if it were any other transactional or 2D data for consideration in our clustering or anomaly detection or whatever. At the end, we've built a nice little flow, and we've been able to review our models and interpret those, all using a very easy-to-use GUI. We can set up more complicated analyses like the one I showed you. We have the simple fraud detection methodology using a one-class support vector machine flow here. But here we have a more sophisticated one where we have the output of clustering becomes the input to separate anomaly detection models. And again, if I want to just go straight into the SQL API or generate the scripts automatically using the Oracle Data Miner GUI, I can do that as well, and I can automate this by just setting up some sort of a schedule to run it at a certain time. If you're interested in learning more, there's lots of material out on the Oracle Technology Network. Just Google for Oracle Advanced Analytics or Oracle Data Mining, in this case is what we're using, and you'll see these free tutorials on how to set up the product and start to use it. And again, if you send me an email, I'll send you my favorite links with links to information, resources, demonstrations, and training materials. It's not really a forum for Q&A here, so I thank you very much for your time. Stay tuned for some more YouTube demonstrations and presentations on Oracle Advanced Analytics. Thank you very much.